And here's another example. Here we go. Again, it's a chain rule. So we're just going to do the 4 bits. So as previously, we're going to start with doing the first partial with respect to x. So it's a chain rule. So it's the derivative of the outside function, which is just 1 over the inside function, times the derivative of the inside function. And x is the variable, so we differentiate this thing, we're just going to get 2x, and the y goes away because it's not a variable. So we get that as our first partial with regards to x. And then if we want to do a second partial with regards to x, so we're going to do that using x again. It's now a quotient rule. So it's the derivative of the top one times the bottom one plus the top one times the derivative of the bottom one. Oops, times, that should be a minus. The derivative of the bottom one. Now remember that x is our variable, so when we differentiate the bottom one, we're just getting that with 2x over the bottom one squared. And you could tidy it up a little bit. We've got 2x squared minus 4x squared will be negative 2x squared, and also 2y squared. So I would probably write that as 2y squared minus x squared over x squared plus y squared squared. And if you want to simplify that a bit more, you may be able to muck around with it, but that's pretty useful. And then the second partial with y operating as the second time around. So we're going to have the second partial of v. We've done one with x, and now we're going to do one with y. So we're going to differentiate this thing, and now y is the variable. So it's the derivative of the top one, which is 0 because it's just a constant, times the bottom one, minus the top one, times the derivative of the bottom one, remembering y is the variable, divided by the bottom one squared, which is negative 4xy over x squared plus y squared squared. Okay, so that's the two partial derivatives based on the first derivative of x. So now we'll do the same thing with the first derivative being y. So again, it's a chain rule, so natural log gives us 1 over the derivative of, 1 over the inside function. So the derivative of the outside function is 1 over, operating on the inside function, times the derivative of the inside function. And because we're doing y as the variable, the derivative of that inside bit is 2y. And now we can do our second partial, so we'll do the repeated y one first. So doing this thing with y, it's the derivative of the top one times the bottom one minus the top one times the derivative of the bottom one, remembering y is the variable, all over the bottom one squared, which gives us something very similar to what we had there before. It's going to be 2x squared minus y squared over x squared plus y squared squared. Okay, so notice that it's not the same, it's very similar, it's just the x's and the y's are swapped around, which makes sense because the function we're working with is symmetrical in x and y. They're both, when you're doing dx's, it plays one role and the dy's will play the same role, so you'd expect the two things to be symmetrical. And then the second mixed one, so we've already done dy, and now we're doing partial x. Notice my language is a bit sloppy there, I'm using partials and d's sort of interchangeably. So I'm doing this thing, and I'm using x as my variable. So it's the derivative of the top one, which is 0, times the bottom one, still 0, minus the top one, times the derivative of the bottom one, on the bottom one all squared, which is minus 4xy on x squared plus y squared squared. And you'll notice again that the two mixed ones are the same, even though the two straight ones, the x twice and the y twice, are different, although in this case symmetrical because the function we started off with was symmetrical.